Let's take a look at graphing equations in two variables. Now specifically, we're going to be looking at first linear equations. So let's talk about that. Linear equations is of this form. You got ax plus by is equal to c. And basically you got x to the first power, you got y to the first power. And a, b, and c can be any numbers. Now we don't have to have all the x's and y's on the left side. Could have a x over here and y over here. The a, b, and c represent any numbers. So again, x and y are the first power, and there's no variables in the denominator. Let me write that down. X and y are to the first power, and no variables in the denominator. Well, let's look at the first problem here. We've got y is equal to 3x squared minus 5. And it says determine whether or not the equation is a linear equation in two variables. Well, we have an x squared. You can only have x to the first power and y to the first power. So this one here would be no. Now here we got 3y plus 2x is equal to 7. Well, we got x to the first power, y to the first power, no variables in the denominator. This is a linear equation in two variables. This is kind of an oddball one. X plus 3 equals 0. Now remember what I said over here, a, b, and c can be any numbers. It can be 0. Like if I put 0 in for b, I get 0 times y, that'd drop away. So this is actually yes. We have x and y to the first power. We don't have y, but we have x to the first power, and there's no variables in the denominator. And our next one, y is equal to 5 over x minus 1. Well, remember what I just said. There's no variables in the denominator. So the answer here would be no. This next problem builds upon what we looked at earlier in a previous lesson. It says graph each linear equation using the point plotting method. So I got y is equal to negative 2x plus 3. Now what we're going to do is we're going to build a t-chart here is what this is referred to as. And you want to pick three x values. When you're doing a line, linear, where everything's the first power, you pick three data points. I'm going to pick, I don't know, negative 1, 0, and 1. And we're going to plug those in. So we got x equals negative 1. We'll plug negative 1 in for the x into this equation here. So we got negative 2 times negative 1 gives us a positive 2 plus 3. And 2 plus 3 gives us 5. So this one would be 5. Now let's plug in 0. So I'll plug 0 in for the x. So we got negative 2 times 0 plus 3. Negative 2 times 0 is 0, so we get 3. So that'd be this y value. And then we'll plug in x equals 1. So we got negative 2 times 1 plus 3. Well, negative 2 times 1 is negative 2. Negative 2 plus 3 gives us a positive 1. So this would be 1. Well, now that we got our 3 points, we're going to plot those. So I got negative 1, 5. Should be right here. I got 0, 3, which would be right here. And I got 1, 1, which would be right here. And after we plot those 3 points, then we draw a line through them, and that would be our graph. And that's the point plotting method. Let's look at another one. So we got 4x minus 3y equals 12. Now, it's kind of your choice, but I find it easier when working these problems if we go ahead and solve for y. So, in solving for y, we're getting rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with a y on one side, so I take negative 3y to the right side, and everything else on the other side, so I take 12 over. So we got 4x minus 12 is equal to 3y. Remember, when you take anything across your equals, sign changes. And we'll divide everything by the number in front of our y, which is 3. So those 3's cancel. And we got y is equal to 4/3 x minus 4. Okay, so let's pick some values now. I'm trying to think if I have enough room up here. Okay, let's come down here. So we'll pick some x values and we'll pick some y values. Now, the x values we pick, if we have a fraction in front of our x, what we want to do is we want to pick multiples of the denominator. See how the denominator is 3? Negative 3 would be a good one. 0 is always a good one. And then 3. When I say multiples, we could have 3 plus 3 is 6, plus 3 is 9, another 3 is 12, 15, 18. But you want to keep them small. Now, it doesn't matter what values you pick, they'll all give you the same graph, same line. Okay, so let's plug in negative 3. So we got y is equal to 4/3 times negative 3 minus 4. Well, this 3 is going to cancel, and we get negative 4 minus 4, which gives us negative 8. And I want to plug in 0. So we got y is equal to 4/3 times 0 minus 4. Now anything times 0 drops away, so that first part's gone, and we got y is equal to negative 4. And we got x is equal to 3. So we'll plug that in for our x. So we got 4/3 times 3 minus 4. 3's would cancel, so we got 4 minus 4, which gives us 0. So this point would be 0. And let's graph this. So negative 3, negative 8. 2, 3, 4, 5, 6, 7, 8. Be right there. 0, negative 4. Be right there. And 3, 0 be right there. Now after you get those 3, draw a line through them. Now the reason why I do 3 points is 2 of them will give you the line, and then the third one is kind of a mathematical check. Now, unless you've done this on graph paper, it's not going to be perfect. So if it's not quite right, make your dot a little bit bigger. Had a professor at Wichita State that called that the big dot theorem. And that would be our graph. Now, next one's an oddball case. So let's take a look at it. And then I'll talk about, after I work this one, I'll talk about the oddball cases. Now, before we solve for y, if you got a single variable like this, then solve for the single variable. So we'll take 3 over, and we get x equals negative 3. Well, if I do my point plotting here, it says using point plotting method. Let's pick values for a y. So we've got negative 1, 0, and 1. Well, if y is equal to negative 1, x is negative 3. If y is equal to 0, x is negative 3. If y is equal to 1, x is negative 3. I think you see the pattern here. No matter what, x is equal to negative 3. That's when you have a single variable like that happens. Well, let's see what that graph looks like. Negative 3, negative 1. It's right here. Negative 3, 0 is right here. And negative 3, positive 1 is right here. So it'd look like that. Well, let's talk about these oddball cases, because once you see them, they're very easy to actually graph. So our oddball cases. Now I'm going to do this by example. So we got x is equal to a number, and y is equal to a number. Well, what makes these oddball cases is there's not two variables. There's only one variable. Now, if you got x is equal to a number, it's a vertical line at that number. So if I go to 2, that would be our graph. Now, if you got y is equal to a number, it's going to be a horizontal line at that number. So this will be y is equal to 3. And looks like that. So right up here, even though they told us to use point plotting for this, the fact I get x equals negative 3, it's a vertical line at negative 3. I wouldn't have to do anything special on that. Now the next thing is talking about intercepts. So let's write that down. Now our x-intercepts is where it touches or crosses the x-axis. And the y-intercepts, a lot of times you just have one, but our y-intercept is where it touches or crosses the y-axis. Let's look at our first problem here. It says find the intercepts of each graph. Let's first look at our x-intercept. Now our x-intercept is where it touches or crosses the x-axis, which in this problem is 6. So you could write 6, or to write it in point form would be 6, 0. Now you'll find here at first in elementary algebra they'll definitely write it in point form. But then as you go on into a little bit into intermediate algebra and college algebra, they'll switch over just writing 6. Now our y-intercept is where it touches or crosses the y-axis, which is 3. So we'll write 3, or to put it in point form would be 0, 3. And those would be our answers. Take a look at this one. Now our x-intercept. That's where it touches or crosses the x-axis. Well, this is a horizontal line at 2, so it doesn't touch the x-axis at all, or cross it. So there is no x-intercepts. Now for our y-intercept, that's where it touches or crosses the y-axis, which is at 2. So I can write 2, or in point form would be 0, 2. Now that's graphically. Let's take a look at how to do it algebraically. Let me start a new page here. There we go. So we got 10 is 5x minus 2y is equal to 20. Well, let's take a look at our x-intercepts. We're going to plug 0 into y and solve. So we took our equation, we got 5x minus 2y is equal to 20, and we said we plug 0 into y. So we got 5x minus 2 times 0 equals 20. Now negative 2 times 0 is 0, so that drops away. And we'll divide both sides by 5. And we get x is equal to 4. So x-intercept wise, this would be 4, 0. Now for our y-intercept, we're going to plug 0 into x and solve. So we got 5x minus 2y is equal to 20. And plug 0 in for x, so we got 5 times 0 minus 2y equals 20. Now 5 times 0 is 0, so that drops away, and we're left with negative 2y is equal to 20. Divide both sides by the number in front of our y, which is negative 2. And we get y is equal to negative 10. And right in point form, if we want to do it that way, would be 0, negative 10. There we go. Now it's easy. When you find the intercepts, you always plug 0 in for the other variable. So if we find x-intercepts, you plug 0 in for y. If it's y-intercepts, we plug 0 in for x. And then we go from there. Let's take a look at another one. So we got x over 3 minus y over 6 equals 2. I'll grab a drink here. Now again, when we're finding an intercept, you always plug 0 into the other variable. So we're finding the x-intercept, so we're going to plug 0 in for y. So we got x over 3 minus 0 over 6 equals 2. 0 divided by 6 is 0, so that drops away. And we got x over 3 is equal to 2. Now we want to get x by itself. This is a linear equation. Get rid of parentheses, get rid of fractions, multiply everything by the LCM of all your denominators. Only have one denominator. So multiply both sides by 3. And those 3's cancel, and we got x is equal to 6. So this point would be 6, 0. Now for our y-intercept, you always plug 0 into the other variable, so plug 0 in for x. So I got 0 over 3 minus y over 6 equals 2. 0 divided by 3 drops away. We got negative y over 6 equals 2. Solving for y, get rid of parentheses, get rid of fractions. Multiply everything by the LCM of all your denominators. So multiply both sides by 6. And that gives us negative y is equal to 12. And then divide both sides by the number in front of your y, which is a negative 1. So this is like negative 1y. So we'll divide both sides by negative 1. And we get y is equal to negative 12. So this point would be 0, negative 12. Now this next one's an oddball. And it's best on an oddball ones to just graph it and look at it. So we got x minus 5 is equal to 0. Remember, what makes this an oddball one is it only has one variable. Doesn't have both x and y. So if I solve for x, I take negative 5 over, becomes a positive 5. Let's go ahead and graph it. X is equal to 5. Remember, x equals to a number is a vertical line at that number. So we're going to put a vertical line at 5. And now let's answer the question. Your x-intercept is where it touches or crosses the x-axis, which is at 5. You can write it that way or do 5, 0. Now your y-intercept is where it touches or crosses the y-axis. And this one doesn't touch or cross the y-axis, so it would be none. Let me start a new page. There we go. Now let's look at the next one. This shows another way of graphing. We got 1/2 x, set of plotting points, minus 2 equals 2y. Now it says graph each linear equation by finding its intercepts. So let's find the intercepts first. Now remember, for our x-intercept, we plug 0 into the other variable. So we'll plug 0 in for y. So we've got 1/2 x minus 2 equals 2 times 0. Which gives us 1/2 x minus 2. 2 times 0 is 0. Now first step, get rid of parentheses, don't have any, get rid of fractions. We do have a fraction. We only have one denominator, so our LCM of those denominators is 2. So multiply everything by 2. Those 2's cancel, leaves us x. 2 times -2 is -4, and 2 times 0 is 0. Solving for x, take a -4 over, it becomes a +4. So our x-intercept would be 4, 0. Now for our y-intercept, we'll plug 0 into the other variable. So we're going to plug 0 in for x. So I got 1/2 times 0 minus 2 equals 2y. 1/2 times 0 drops away, so we got -2 equals 2y. Divide both sides by a number in front of our y. So we'll divide both sides by 2. And we get y is equal to -1. So this point would be 0, -1. Okay, now this tells us to graph it by finding its intercepts. So we just found its intercepts. We said the x-intercept is 4. So we're going to go to our x-axis and we'll put a dot at 4. Our y-intercept is -1. So we'll go to a -1 on our y-axis and we'll put a dot. And after you get those, you draw a line through them. Usually you don't need to pick a third point on that, because if you find the intercepts, when you plug 0 in, things drop away really nice, and you don't have to worry about math mistake as much. Doesn't mean you still can't make it, but you don't have to worry about it as much. And let's look at another oddball case. This says graph each horizontal and vertical line. Kind of gives it away. From the fact that we only got one variable, that tells us it's an oddball case. Well, what we have to do is we have to solve for that variable. So we'll take the -6 over to the right side, and it becomes a +6. Divide both sides by a number in front of your x, which is 3. And we get x is equal to 2. Those 3's cancel. Remember, if you got x is equal to a number, it's a vertical line at that number. So we're going to go to 2. And we'll draw a vertical line. Now if we had y here, you'd do the same thing. You want to get the y by itself and then be a horizontal line at that number. And that's the last problem here, so let me stop the recorder.